The next speaker is from PharmaHub. I know I'm going to mangle her name, so I think I'll let her introduce herself. Can you pronounce your name?
Elcin Icten.
Yeah, that's. I would have done a bad job of that. Happy to have you here today. She'll be talking about a HUBzero component for experimental knowledge management and data analytics that they've been building inside of PharmaHub. So welcome and thanks for being here.
Hello, everyone. I hope you can hear me. Today, I'm going to present you the HUBzero component for experimental knowledge management and data analytics. Do you have the clicker point? Yeah. Or.
It's one up there,
Okay. Okay, that's fine. Yeah, sorry. So here's my outline. First, I will explain you give some details about the workflow-based knowledge management system we developed with HUBzero as a HUBzero component. And I will talk about the workflows and data provenance. And then I will explain you how we use the KMS system with the Dropwise additive manufacturing system for pharmaceuticals, and how we integrated the KMS with the automation system, and how we use that for data extraction and presentation capabilities. So the workflow-based knowledge management system functions as a HUBzero component. And workflows capture the information creation process, and they are organized as a network of tasks and subtasks. And the attributes provide structure for recording relevant information. So workflows can be modeled graphically as a network. So this allows an intuitive, high-level representation of the process, and it provides a logical structure to organize, store, and retrieve information. So there are different workflow types. Mainly, I will talk about the scientific and experimental workflows. And in the scientific workflow, you can extract data and then run your model. In this case, it's shown as the multilinear regression model. And then you can get the data created by the software. And in experimental workflow, you can define your experiment as a workflow, as a graphical network. So since we have different workflows, we also need different data nodes. We need to use different data nodes. So for scientific workflows, we use input data and data created by software, which are so input data and the data created by the software. And for the other workflows, we have client-side uploaded data, links to external data, and data to be extracted from specified repositories. And for all data nodes, the metadata is saved and it can be retrieved later. So the process of creating raw data or transforming data is a part of data provenance. And this is crucial for verification, reproducing, creation of transformation, and developing extensions, and also for training and instruction purposes. And especially in research and manufacturing, it is very important to capture data provenance, especially for the pharma industry, where you need to report to a regulatory agency, such as the FDA in the United States. So there are benefits of the workflow-based approach. I will not read through all of them. So a network can be tailored to the underlying operational procedure. It's a consensus builder tool between collaborators. And you can use this for data entry as well as data retrieval. And you can access each data item in a maximum of 4 tuples. So here are some system details. So the KMS system is available and it's implemented on HUBzero. It consists of a graphical workflow editor, which is a TLC TK application. And the KM user interface is a server-side PHP application using MySQL. And workflow execution engine is implemented using JavaScript and PHP, and it also uses Ajax. So this is how the workflow editor looks like. First, you only have 6 icons. So the first blue icon is the workflow icon. If you click that, you will get the blue box, which says TB3 nozzle calibration workflow in this example. So this will represent your workflow. And then If you click on that, you will get this menu, where you can select task, data mode, material sync, or material source, and the submit button. And then you can build your experimental workflow. Also, from each task, you will be able to select different subtasks, which are represented with white boxes. And you can specify the parameters for each subtask. In this case, for setup subtask, we specified pump speed, pump displacement, and different other parameters. So here, each subtask performs an action. You can select the action type. It can be experimental, scientific, or a recipe. And then you can select an action, which can be record information, execute library program, or invoke a workflow template, or execute a program. And then you can set up additional parameters. So scientific subtasks have 3 main categories of actions. So you can execute a library program where a full factorial design of experiments can be run, or a simple linear regression, data extraction, graphing data, or a profile can be created, and you can run some basic statistics tools. And also, you can invoke a workflow where you can create an instance of the identified workflow and the set known parameters with generated values. And after the instance is completed, you can generate another instance if necessary. And you can also execute a server-side command. So after this introduction, now I will explain you how we use this KMS for experimental data management and analysis. So our system is a Dropwise additive manufacturing system. So we developed this system at Purdue with an NSF Engineering Research Center for structured organic particulate systems, so basically for pharmaceuticals. So this is an innovative pharmaceutical process which aims to produce individualized dosing. So we are using the drop-on-demand inkjet printing technology for the deposition of the drug onto an edible substrate to create individual doses, drug doses. So here's an actual picture of the process. It's a very compact mini manufacturing process, and it can be used to produce clinical trial dosage, where you can change the dosage amount between different patients. And you can produce individualized dosage at a clinic or a compounding pharmacy, which will facilitate personalized medicine. So here, in the middle of the picture, you can see the different process units. So I will explain you the process very basically. So we have the reservoir containing the pharmaceutical formulation, and which is printed using a precision positive displacement pump onto the edible substrate, which can be inert tablets or polymeric films. And we capture an image of each ejected drop and calculate the drop volume, which corresponds to the dosage amount for in each drop dose produced. And on the right-hand side, you can see the user interface of the automation program. And on the left-hand side, we have various controller boxes. So these are some of the products we produce with the system. So we can deposit solvent-based formulations on polymeric films, or melt-based formulations on polymeric films or inert tablets. And so we integrated the drop-on-demand manufacturing process with the knowledge management system. So this is the experimental workflow of the DoD system on the knowledge management system. So here, KMS gives us the ability to produce an intermediate text file containing the parameter values in the order expected by the LabVIEW data loader. And then we load that file to LabVIEW, and then LabVIEW runs the DoD manufacturing system, and then it saves the output file in another CSV file, and then we upload this back to the KMS system. So let's see how we specify each task and subtask. So first we start with the material source. You specify the formulation parameters, and you specify the substrate parameters. Then you can specify the reservoir subtask parameters. And then printing settings, you can specify the nozzle parameters, different staging. So you can change or manipulate the parameter values, the printing settings associated with the system. And then after that, you can go back to the workflow icon and then create a file for transfer, which will generate an intermediate input file. It contains printing settings and deposition pattern and computer and the temperature controller options and temperature set points, which we just specified in the KMS. And it has this, it is a CSV file and it has this format. The first line is has the parameters, the second line are the units, and third line are the numeric values corresponding to those parameters. So we upload this intermediate file to the LabVIEW-based automation program. So the data is automatically inputted, is read from the input file, and it is shown on this GUI to help the user. And then the process starts running automatically, and the output files, along with the drop images, which look like this for all the drops, are saved. And then you upload that back to the KM, and this completes the dose provenance. So this is how the output file looks like. So it contains drop information, image analysis results, including drop volume and center of volume calculations, as well as the image file name and the printing settings. So here again, the first row corresponds to the parameter values. The second row are the units. And starting with the third row, each row corresponds to one individual dose. So it will give you the timestamp, the location on the staging, and all the process parameters, along with the image file name, so that if you would like to, if you need to report that information later on to a regulatory agency, you will be able to pull up that information as well. So we are saving all this data, but we also want to extract data and use that for later analysis. So therefore, we are using a graph data workflow, which is a scientific workflow. So for that, you select a menu from, you select a template from a menu of instances you created previously. So in this case, we can select the workflow as a TB3 basic experimental, and then we can select different experiments, different workflows. And then you can specify which variables you would like to analyze. And then you find the columns of that corresponding data. And then you can actually plot this data. So in this graph, we have 6 different runs plotted. So here we plotted on the y-axis, we have the drop volume, and on the x-axis, we have the drop numbers. So we have, we use 2 different printing settings, which are rate 400, displacement 2.5, and volume strokes for the top 3 experiments. And they are different for the bottom 3 experiments, which is written here. So here our aim is to see how reproducible the drop generation process is in between different runs. And so we use the basic stats workflow to calculate the average drop volumes, the standard deviations, and the relative standard deviations associated with these runs. And you can see that you can record the experiments very easily and then later on use that information. So we also developed an operating regime workflow because in this process, the material properties affect the drop reproducibility and the production quite a lot. So therefore, we built this experimental workflow where the material source is selected from previous TB3 basic experiments, and the operating regime is specified for each formulation used in the experiments. So later on, if we would like to do another experiment, you can go to KMS and then see where the operating region is best, which is shown in this graph in this case, and then you can select one of the operating settings that is shown as most favorable, and then select that setting and run new experiments with that. So to conclude, we developed a workflow-based knowledge management system which functions as a HUBzero component, and it can use different workflow types. And we use this KMS system on a drop-on-demand based manufacturing process for pharmaceuticals to manage and analyze experimental data. And the data provenance of individualized doses is issued. And I would like to mention that this KMS, along with the DoD manufacturing system, was used by a team of undergraduate students during their summer research internship this past summer, and they really enjoyed working with the KMS and then be the first people who tried that out. So I would like to acknowledge my advisor, Professor Eklaitis, and Girish Joglagar, who actually built this KMS system with Arun Giridhar as well. And I would like to thank my undergraduate researchers, Chelsea, Kristen, and Jennifer, and also NSF Engineering Research Center for Structured Organic Particulate Systems, and INMAC for the funding support. Thank you. I can answer any questions if you have.
Yeah, sure.
So if you need to add a new workflow, who would program it and how long would it take to add?
With the workflow editor, it's you can build your own workflow. Actually, so this was one application on the drop-on-demand system, but we also have a continuous tablet manufacturing and also continuous crystallization processes. So they're the I guess they are all PhD chemical engineering students, but they are all developing the workflow themselves.
Because you mentioned those types, if you need a new type, I was wondering what kind of involvement needs to go in there.
I believe it's already developed, and you will need to build your own workflow, but if you would like to edit that, I'm not sure how, probably Girish or like somebody else would know that.
I guess there are things like tasks and subtasks,
Yeah.
but you can use those, compose them in different ways, and add parameters. But I suppose what Carol's saying is if you needed something else that's completely different, then that's more development. But so far, the building blocks that you have, you've been composing workflows, and they've been working fine. Is that right?
Yes, yes. But yeah, you will need to develop new tasks or additional items, I guess.